Okay, these are the examples for Geometry A, Credit 1, Lesson 1.3. All right, so what we're going to be doing here is trying to determine the translation rule to go from our pre-image to our image. And we're told that this is the pre-image, we're told that this is the image, but even if we weren't told that, we could determine that from the way the triangles are labeled. So notice this triangle is labeled ABC, and this triangle is labeled A prime, and that little apostrophe, that's how we read that, A prime, B prime, and then C prime. And so we always go from the figure that doesn't have the primes, the little apostrophes, that's our pre-image. We go from that to our image, the one that has those markings that we call prime. All right, so to determine the rule, it's just a matter of counting squares. And so let's go ahead and start writing our rule. So our translation rule, the rule that we'll use to determine how this figure was moved from here down to here. And the way we'll do that is we'll pick a pair of corresponding points, meaning either A and A prime, B and B prime, or C and C prime. I'm going to use B and B prime just because it feels a little more convenient here. But again, any pair is fine. So to go from B to B prime, so first of all, that's going to be, we're going to move to the right. So that's going to be our X movement. And so to go from B to B prime, we're going to have to move to the right. So that's going to be in the positive direction. So that's 1, and we're just counting the squares, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares. So plus, we're going to the right, so plus 10. So our rule is XY translates or moves to or becomes X plus 10. And then now we're going to get to B prime, we have to go down 1, 2, 3, 4, 5, 6, 7 squares. And so that's our Y direction movement along the Y or parallel to the Y axis. So that's up and down is always Y. And since we're going down, that's minus. And so that would be minus 7. So the rule that describes this translation is that any point XY on this figure, we have to move it 10 units to the right, X plus 10, and then 7 units down. So that's how we determine the rule for a translation, always going from the pre-image to the image. All right, so that's your examples for problems 1 and 2. And now let's take a look at an example for problems 3 and 4. And let's go ahead and draw that up. So on 1 and 2, what we did was determine the rule. Now what we're going to do here is apply the rule. So let's go ahead and draw another triangle here. And let's say we have this. And let's maybe go up to here. And so let's call this triangle, make that a little bit better if we can. We'll call that triangle ABC. And so what we're going to be given here is to apply the rule. And the rule that we're going to apply here is X plus 7 and Y minus 2. And so that what that means is that we're going to move the figure plus 7 along the x-axis, so 7 to the right, and then 2 down, 2 in the negative direction along the y-axis, so 2 down. And once again, even though we don't need to, let's go ahead and put this in another color here. So now, again, we said every point on the figure is going to follow this rule. The easiest way to do this is just do that for each of the vertex points for A, B, and C, and then we'll just connect those and we'll have our figure. So let's go ahead and move it. We'll start with B, 2, 4, 6, 7, and then down 2. And then we'll do, let's do C. We have 2, 4, 6, 7, and then down 2. So again, 7 to the right, 2 down. And then finally for A, 1, 2, 3, 4, 5, 6, 7, and then down 2. And so we're going to label those appropriately. This was B, so this is B prime. This was C, so this is C prime. And this was A, so this is A prime. And we're going to connect those points. And if we did everything right, we should have a congruent figure, a figure that's the same size and shape as our original figure, except that it was moved 7 units to the right and 2 units down. So once again, this is our pre-image. That's the one we started with. And the figure over here, this is our image, the one we ended up with. So that is your example for problems 3 and 4 for the 2 figures we have here. All right, so now the other thing they're going to ask you is identify a point on the image once you've translated it. So let's go ahead and actually identify all the points here. A prime is at 1, -1, 1 to the right, 1 down, so it's at 1, -1. B prime is 1 to the right, and then 2, 4, 6 up, so 1 and 6, 1 to the right, 6 up. And then finally, C prime is 2, 4, 6 to the right, and 1 down, so 6, -1. So again, in the packet, they're only going to ask you to identify one of these points, but just for practice, we did all 3 here. So that's your example for problems 3 and 4. All right, so now for number 5 on the back, let's go ahead and set that up. And so let's take a look here at what we're going to be doing. So what we're going to do here is we're going to start out with we're going to use the same points as starting points. We're just going to apply a different rule. And what we're dealing with on number 5 is something called a dilation. And a dilation is when we take a figure and not move it as with a translation, but we're going to actually either take that figure and make it larger, which is what we'll be doing in number 5, or dilation could be even to make the figure smaller. And so a dilation will be the same size, the same shape as the original figure, but not the same size. So let's say that again to clarify. A dilation, the image, the result, will be the same shape, but not the same size. And that's what we'll see here. All right, so let's start by plotting the points for our pre-image. We have points at, let's see, we're going to set this up, maybe down here. So we have A is at 1 and 3, B is at 5 and 1, and then C is at 3 and 4. So these are the same points that you will be using on problem number 5. And you will have to plot these. So this will give you a little practice. Maybe try plotting them now, stopping the video. But here's how you plot those points. So 1 and 3 would be 1 to the right and 3 up. And so that's A. B is 5 and 1, so 5 spaces to the right and then 1 up. That's B. And then C is 3 and 4, 3 to the right and then 4 up. And so that's our small triangle here that we're going to plot. All right, so there we go. So now what's going to be different from what you're it's the same type of work, but what's going to be different from the problem in the packet is the rule. So the rule we're going to apply to these points for the dilation is xy translates into, and make sure we get this right, 3x and 2y. Now be careful. In the packet, I think the 2 and the 3 are reversed, so just careful on that. So that's how, by applying that rule, that's how we're going to get A prime, B prime, and C prime. So what is this rule? What does that mean? In fact, let's go ahead and put a box around it just to emphasize it. So what that means is that each x coordinate is going to get multiplied by 3, because remember, a number next to a variable indicates multiplication. So each x coordinate gets multiplied by 3. Each y coordinate gets multiplied by 2. What I found is helpful for me is to do all the x coordinates first, because then you're not going back and forth, multiplying by 3, multiplying by 2, and you might, I know I could get confused. So let's go ahead and do that. So each x coordinate, we're going to multiply by 3. So 1 times 3 is 3. 5 times 3 is 15. And finally, 3 times 3 is 9. And so those are going to be the x coordinates. The y coordinates, different rule, we're multiplying by 2. So 3 times 2 is 6. 1 times 2 is 2. 4 times 2 is 8. And so those will be the coordinates of our image, 3 and 6, 15 and 2, 9 and 8. So let's go ahead and plot those. We will do those once again in a different color, just so they stand out. So A prime is going to be at 3 and 6. And I just realized we're going to need some space here. So we'll move that. So 3 and 6. So that would be 3 to the right and then 3, 6 up. So that'll be our A prime. 15 and 2 is our B prime. So let's count this carefully. 3, 6, 9, 12. Make sure we did that right. 3, 6, 9, 12, 15. So 15 to the right and 2 up. And you can already kind of see that this figure is going to be much bigger than the image will be much bigger than the pre-image. And finally, C prime is 9 and 8. So we're going to go over 3, 6, 9 to the right, 2, 4, 6, 8 up. And that'll be C prime. And so we're going to connect those points, and we have our dilation. And so once again, notice that while the figure is the same shape, allowing for maybe me not drawing it perfectly, but it's pretty good, I think. Same shape, it is definitely not the same size. Now, one other question that they're going to ask you there is it says the resulting image is a rigid or non-rigid motion. All right, well, it's only a rigid motion if they are, the two figures are the same size and the same shape. Well, they are the same shape, but they're not the same size. So this would be a non-rigid or not a rigid motion. So we'll write it like they do in the packet. So this would be non-rigid. And so a dilation typically will not be a rigid motion because you're either going to take the pre-image and make it bigger, the resulting image will be bigger, or you would take it and make it smaller. In either case, that's a non-rigid motion. All right, that is it for the examples for lesson 1.3. Again, rewind, pause the video as needed, and good luck with the work. We'll see you in the next video, and God bless. Bye-bye.